and welcome to this revision session for AQA A-Level Physics Paper 1. So in today's revision session we're going to look at how to answer examination questions on A-Level Physics Paper 1. So if we've been successful and we've learned in today's revision session, we should be able to answer A-Level Physics examination style questions, assess our understanding on A-Level Physics to understand what topics we need to improve upon for AQA A-Level Physics. So when carrying out this revision session, you should divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this section write down your working out and answers to the questions in the revision session. When you're doing this, make sure to write in full sentences and show your full working out. Whilst in the right hand side section, write down any piece of information which you find useful or any hints and tips on answering questions from this revision session. After the end of the revision session, write up these notes into a revision sheet for you to use independently. So how should you be revising A-Level Physics? So the first step is to learn the key facts. So use the revision guides, class workbooks, student prep notes, textbooks to learn the key ideas of the course. And you might wish to make mind maps or write out notes yourself. The second step should be to test yourself. So use things like Caboodle, Seneca, knowledge checkers to quickly test your own knowledge, and this could be done from your own cue cards. And then finally, the third step is to practice examination questions using things like exam prep books, homework books, supervised study books and additional workbooks to answer exam questions and mark your own work, and you may wish to download your own examination papers to help do this. So the three steps of learn the key facts, then testing yourself and then practicing exam style questions are how you should be revising AQA A-Level Physics. So let's now practice some questions for AQA A-Level Physics Paper 1. So the first topic is particles and radiation. So answer the following question. Electrons and positrons each have a rest energy of 0.511 MeV. State what is meant by rest energy. In figure 1 shows an electron and positron travelling towards each other just before they collide. Each particle has a kinetic energy of 0.340 MeV at the point of collision. Describe with reference to the energies involved the outcome of the collision. So pause the video now, then unpause the video when you want to go through your answer. Right, so how to answer this question? Well, you've got to firstly know what the definition of rest energy is in terms of particles. So rest energy is the energy equivalent of the mass of the particle when it's stationary or when it has a kinetic energy of 0. Now for the second question, you've got to consider the information AQA have given you in the question. They've mentioned it's an electron and it's a positron, so therefore they are the particle and antiparticle pair. So it's asking you what will be happening when a particle and antiparticle collide with each other. In addition, it's give you the kinetic energy and the rest energy of the particles, so you can refer to that in your answer as well. So you'll know that the electron and positron will annihilate as they're a particle-antiparticle pair. They will produce two gamma photons, producing two photons to conserve momentum as they're traveling in opposite directions, and the total energy of each will be the kinetic energy plus the rest energy, which will be 0.851 MeV. So the next question says, a beta minus particle is emitted when a nucleus of strontium-90 decays into a nucleus of yttrium. Firstly, explain the origin of the beta minus particle, then state the values of A and Z for the yttrium nucleus, and then third, in early studies of beta decay, the kinetic energies of the beta minus particle were measured. Explain how these measurements improved our understanding of what happens in beta decay. So pause the video now, then unpause the video when you want to go through your answer. Right, so the first question is asking you fundamentally what is going on in beta decay. Now you've got to remember that beta decay takes place in the nucleus, so it's when a neutron in the nucleus will decay to form a proton, an electron and an antineutrino. So you'll need to be aware of what the beta decay process is. Now you should hopefully as well notice what happens to the value of A and Z in the beta decay. So A stays a constant value and Z will go up by 1, so the answers are 90 and 39. That's the same for all beta minus decays. And thirdly, it's asking you why the kinetic energies of the beta minus particles were not going to be constant. Well, they're not constant, and there's a range of kinetic energies up to a maximum because there's something else released in the decay along with the beta minus particle, because whilst the total energy is constant, it's shared over multiple particles. So that showed us we had to hypothesize the idea of the neutrino, and it actually found related to be the antineutrino to conserve lepton number was also produced in the decay process. The next question says, the following equation applies to the photoelectric effect. State what is meant and what is represented by the terms HF and EK max, and state and explain what is represented by the term phi. So pause the video now, then unpause the video when you want to go through your answer. So to answer this question, it's really important that you understand what each term means in the photoelectric effect equation. So HF links into the energy of the photon itself, whilst the EK max refers to the maximum kinetic energy of the electron emitted in the photoelectric effect. It's very important that you've got to remember what is the photon and what is the electron emitted from the absorption of the photon in the photoelectric effect. Now for this next one, you've got to understand that phi is the work function. That's a fact you've just got to remember, and it is the minimum, and you've got to remember, you've got to put the word minimum in there, energy required to remove an electron from the surface of the metal. Not just the metal itself, but the surface as well. Now in the following question, it says figure 6 shows a circuit used to investigate the photoelectric effect. The ammeter can measure very small currents. Monochromatic red light is instant on the metal surface of the cathode, and the current in the ammeter is 0. The red light is replaced with monochromatic blue light, and there's a current in the ammeter. Firstly, explain why there's a current with blue light but not red light, and then the intensity of the monochromatic blue light is increased and the experiment is repeated. State and explain any change in the current. So pause the video now, then unpause the video when you want to go through your answer. So when you're answering this question, you've got to always remember, what does the colour or frequency show you in the photoelectric effect, and what does the intensity show you in the photoelectric effect? Well, you've got to remember that colour or frequency links into the energy of the photon, which is required to liberate the electron. So the blue light photon is going to have more energy than the red light photon, because the blue light has a higher frequency. So therefore E equals HF. If F is higher and H is a constant, well therefore blue light photons will have more energy than red light photons. So that then tells you that there's enough energy above the work function for the blue light, but the red light photon has energy below the work function, so cannot allow the electron to be liberated. Now in the next question, you've got to always remember that intensity is how many photons hit the surface every single second. But it's always important to note in the photoelectric effect equation and in the photoelectric effect itself that one photon is instant with one electron. There's a one-to-one relationship between photons and electrons. That's a very, very common marking point for photoelectric effect equations. So therefore, if there's more photons every second and one photon interacts with one electron, that tells us that more electrons are going to have photons absorbing into them, so more electrons are ejected and therefore the current will go up. The next question says a sigma plus particle and an unidentified particle Y are produced by the strong interaction between a positive pion and a proton. The interaction is represented by the following equation. Complete table 1 to show the baryon number B, charge Q and strangeness S for the particles in this interaction, in which particle in table 1 has the quark structure UUS. So pause the video now, then unpause the video when you want to go through your answer. Right, so this question is all about what the different properties of the particles are. So you'll notice that with a proton, a proton will have a baryon number of 1. That's a fact you've got to remember. Whilst a pion, because you know that it's going to be a meson, will have a baryon number of 0. So if it's 0 and 1 before, if baryon number before equals baryon number after, that tells us that sigma plus also has to have a baryon number of 1. Now you know the charge of the pion plus is +1, of a proton is +1. Of sigma plus it's +1, so Y must also be +1 for the charge to be 2 before and 2 afterwards. Now you know that both the pion and the proton are not strange particles, because we know the only strange meson is going to be a kaon, and we know the proton from its structure itself is not going to be strange, so that's 0 and 0, so therefore the sigma plus has to be -1 for the strangeness to be 0 before and 0 after. Now you'll note in the question it tells you it's a strong interaction. interaction. So in strong interaction, strangeness has to be conserved. Now in the next one, which has the quark structure UUS, well, you know, if it's got 3 quarks in there, it's got to be a baryon, so therefore it can't be pi plus because we know that that is a meson. We know it can't be Y because that has a baryon number of 0, so it can't be a baryon. So there's only 2 options. You've got the proton and you've then got sigma plus. Now there's 2 ways you can think of doing this. Either you know what the proton structure is, which is up up down, or you can look at the fact that sigma is already indicated to have a non-zero strangeness, so that must have a quark structure with a strange quark in it. So the answer is sigma plus. The next question says, deduce with which particle pi plus or Y has the greater charge to mass ratio and justify your conclusion. So pause the video now, then unpause the video when you want to go through your answer. Right, so how to answer this particular question? Well, you can tell firstly that Y has a greater rest energy than pi plus. And why is that? Because we can tell from our previous question that pi plus and Y had the same charge because they both identify as having a charge of +1 from the previous question. Now you know that Y is going to have to be a kaon. Why is that? Because it has a non-zero strangeness and it has a baryon number of 0, so it's a strange meson, so therefore it must be a kaon. So therefore we can tell that pi plus has the greater charge to mass ratio because it has the same charge as Y but will have less mass, because we know that if it's pi it will be made up of up and down quarks which have less mass than the equivalent strange quark. So therefore what pi plus will have a greater specific charge, which is the charge to mass ratio. We will now be looking at questions to do with waves in physics paper 1. The following question says, a screen is placed 3 meters from a diffraction grating as shown in figure 10. The screen and the grating are parallel. Monochromatic light of wavelength 540 nanometers is incident normally on the diffraction grating. The central maximum appears on the screen at O. The first order and second order maxima on each side of O are seen at positions A, B, C and D. The distance between A and D is 1.32 meters, so that the angle between the 2 second order maxima is approximately 25 degrees. Calculate the number of lines per millimeter on the grating. The instant light is now replaced with monochromatic light of a different wavelength. More maxima are observed on the screen. State and explain any other change in the appearance of the pattern on the screen. So pause the video now, then unpause the video when you want to go through your answer. So in this question, what you firstly got to consider is the triangle that is produced between the parts of A, D and the part where the monochromatic light goes in. So what you should be doing is drawing a triangle in. It's always a really good idea that when you're looking at diffraction gratings and have a diagram like this, that you can draw in your right angle triangle, you can then work out your angle via SOHCAHTOA. So what you'll see is straight away that you'll have the opposite and you'll have the adjacent because they're clearly labelled in the diagram there. And then what that does is that then allows you to then work out what your angle is going to be. Now remember, the right angle triangle will go from where the monochromatic light is to O to A. So if you want the angle from A to D, you're going to have to double the angle that you are working out there, which is why the answer has been doubled. The next one, you've got to use the equation d sine theta equals n lambda. Now you've always got to remember as well, whilst it's not given to you in your examination, that the number of lines per meter is equal to 1 over d. So what you would do is you pop in your values, and again remember you've just worked out the angle from O to A, which is going to be 12.4. You know what your value of n is because you told it is the second order that it goes to, and you have your wavelength is 540 times 10 to the minus 9. Remember, nanometers is times 10 to the minus 9. You can then use that to work out your value of d, and then work out the lines per meter by doing 1 over d. Then you've got to convert it into millimeters because it is lines per millimeter, so you should get your answer of around about 200. Now the last question really wants you to think about what the pattern on the screen is going to be. So if you think about the fact that there are more maxima observed on the screen, the angle you are going to be working out in your equation d sine theta equals n lambda is going to be smaller because there are more orders on the particular screen, so therefore the angle is lower. So because you got your angle lower, that tells you that there's going to be a shorter wavelength because d sine theta equals n lambda, so it has a shorter wavelength. It'll appear bluer than it did before. If you look at the next question, it says figure 1 shows sunglasses that have a polarizing lens. The sunglasses are sold with a separate small polarizing filter. State and explain how the filter can be used to check that the lenses are polarizing. So pause the video now, then unpause the video when you want to go through your answer. Right, so for this particular question, it's fundamentally asking you how do you test whether lenses are polarizing, and there's a standard experiment you can do. So you hold your two Polaroids, so in this case the sunglasses and the polarizing filter, rotate one about the other from 360 degrees. Now you should see that if it is polarizing, that there should be a change to the intensity of the radiation that can go through the two Polaroids. Now if they are completely aligned, so at 0, 180, 360, they should all go through, so should be the maximum brightness, and when they're at 180 or 270, in 90 or 270, my apologies, they're at right angles to each other, so nothing should be able to get through, and you get a minimum of radiation going through. The next question says the critical angle for light travelling from diamond to air is 24 degrees. The critical angle for light travelling from glass to air is 42 degrees. Explain what can be deduced about the relative values of the refractive index of diamond and the refractive index of glass. So pause the video now, then unpause the video when you want to go through your answer. Right, so this question is all about using the equations that you were given on your equation sheet. So you should see on your equation sheet that sine critical angle is equal to 1 over n. So we can tell at this point that if the critical angle is equal to 1 over n, or sine critical angle is equal to 1 over n, that diamond must therefore have a much larger refractive index than glass because the critical angle is much lower. The next question says, a satellite system is used to measure the height h of the top of an ice sheet above the surface of the ocean. The satellite emits two pulses, A and B, of infrared radiation. A is incident on the surface of the ocean and B is incident on the top of the ice sheet as shown in figure 2. Firstly, the frequency of infrared radiation is 3.8 times 10 to the 14 Hz. Each pulse has a duration of 6 nanoseconds. Calculate the number of cycles in each pulse, and then A and B reflect and return to the satellite. The travel time is the time between the emission of a pulse and its return to the satellite. The difference in the travel times of A and B is 10.7 microseconds. Calculate h. So pause the video now, then unpause the video when you want to go through your answer. Right, so for this one, what you've got to do, in your first question, you've got the frequency and you need to work out the number of cycles in each pulse. So we know that frequency is 1 over time period. So therefore we can work out what our time period is going to be quite easily. Time period is 1 over frequency, so therefore it works out to be 2.63 times 10 to the 15 seconds. Then we know, if you look on the previous question, that each pulse is 6 times 10 to the minus 9 seconds. So therefore you can work out the number of waves by doing 6 times 10 to the minus 9 divided by the time that we've just worked out to get 2.3 times 10 to the 6 waves every single second. 2.6 cycles in the pulse, sorry. Now the next question, what you're going to have to do is, because it's reflecting, we're going to be doing the equation speed is equal to distance over time. Now we know what the speed is going to be because we know, if we read the question here, it says infrared radiation. So we know infrared radiation has a speed of 3 times 10 to the 8 meters per second because it's an electromagnetic wave. Then we can work out what our time is going to be, because we can say for that time is distance over speed. Okay, and then we can work it through like that. We're going to work out the distance, don't we? So we can then work out what our time is going to be by doing 10.7 times 10 to the minus 6 over 2 to get our time period to be 5.35 times 10 to the minus 6 seconds. So we pop that into our equation where distance is equal to speed times by time, and we get 1.6 times 10 to the 3 meters. Now note, why have we halved the time? Well, because we've measured the time it takes the pulse to go there and back. So if we're trying to work out the distance to there, we're going to have to halve the time because we only want the time to there. The next question says, some of the infrared radiation enters the ice sheet. Figure 3 shows the path of infrared radiation that refracts at the sloping part of the ice sheet. Calculate the refractive index of the ice, then calculate the wavelength of the infrared radiation when it is inside the ice shield. Right, so how do you answer this particular question? Well, if you look on this question, you're going to have to use the equation n1 sine theta 1 is equal to n2 sine theta 2, and you pop in your values and you work it out to be 1.3 for your refractive index. Now note, it's very important that the angles are always taken from the normal, so you wouldn't be using 38 in this particular question because it's not from the normal. We would do a 90 minus 38 when we're trying to work it through. Remember that the refractive index of air, which we'll call n1, 1 is going to equal 1 in this question as well, so therefore we can use that to work out what the refractive index of the ice will be. So then how do you calculate the wavelength of this? Well, then we can say n equals c over cs, and then we can work out what c is going to be by doing c equals f lambda. So therefore you've got your frequency, you've got your wavelength. Okay, so at that point you can then work out what your speed is going to be by doing one over the other, and then you can work out your answer to be 2.3 times 10 to the 8 meters per second. We're now going to look at questions involving mechanics and materials. So in this first question it says figure 3 shows a stack of plates in a plate holder used in a hotel kitchen. The stack of 13 plates is supported by a spring. The spring is compressed by 16.7 centimeters when there are 13 plates in the stack. Each plate has a mass of 0.61 kilograms. The spring obeys Hooke's law when supporting 13 plates, and the masses of the base and the spring are negligible. So calculate the stiffness of the spring. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you work this through? Well, stiffness is another phrase for spring constant. So you look on your equation sheet and you see that F equals K delta L, so the extension. Now we also know that the force in this case is going to be the weight of the plates. So we can do F equals mg. Now we know that there are 13 plates here, so it's going to be 13 times by 0.61 times by 9.81 to get your weight. We can then say F equals K delta L, so therefore K equals F over delta L. Now remember, delta L is going to have to be in meters, so it's going to have to be 16.7 centimeters in meters, so 16.7 times 10 to the minus 2, and you work out your answer to be 470 newtons per meter. The next question says calculate the energy stored in the spring when there are 13 plates in the holder. Then when a plate is added, the spring compresses so that the base moves downwards by a distance equivalent to the thickness of one plate. This ensures that the top plate is always above the surface of the holder. Over time the spring becomes weaker and its stiffness decreases. Explain how the behaviour of the plate holder will be affected by the decrease in the stiffness of the spring. So pause the video now, then unpause the video when you want to go through your answer. Right, so for this question you need to look on your equation sheet and you see E is equal to half F delta L, or you could do a half K delta L squared. Now we know what F is, it's going to be our weight again, so we've got our weight from our previous question. We've got delta L, remember again we work in meters, we pop them in there and we get 6.5 joules. Now in this next question it's very important you don't just give general facts about physics, but rather you answer the particular situation and scenario given in the question. So what you'll notice is that if we have a decrease in the stiffness of the spring, well that tells us that the spring constant or stiffness is the force needed to extend it by 1 meter. So therefore you would need less force to extend it by 1 meter. So this tells us that the plate was compressed more because you don't need as much force to compress or extend the spring. So to link it into the question asks the plates will now be well below the top of the well, so it'll be unlikely to see them. The next question says a falcon is a bird of prey that catches other small birds in flight. The falcon dives to increase its speed. Its gravitational potential energy decreases by 1,900 joules during the dive. The mass of the falcon is 1.1 kilograms. Calculate the vertical distance moved by the falcon as it dives. Then the initial vertical speed of the falcon is 25 meters per second. During the dive, the falcon's wings applies a vertical force downwards, transferring 1,400 joules of work. Calculate the maximum theoretical speed that the falcon could achieve in this dive. Then in practice the falcon will need to transfer more than 1,400 joules of work to achieve this maximum theoretical speed. Explain why. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first question, you know you're given the energy here. Now again, you're not given enough information to use SUVAT, so you've got to use the energy stores in this situation. You're told the gravitational potential energy change, and we're trying to work out H, or the vertical height difference. So EP equals mgh, work it through and you get 176 meters or 180 meters to two significant figures. Now in this next question again, you don't have enough information to use SUVAT, so you've got to use the changes in energy store. So you'll notice that when it's starting, it has an initial speed, so it has an initial kinetic energy, and then it will also have work being done on it, and will also have gravitational potential energy as it is high up. Now the maximum theoretical speed is when all these energy stores will go into into the kinetic energy store, and you can then use that to work out the speed of the object. So you can work out your initial kinetic energy with a half mv squared, add it to the work done, which is given in the question, and the gravitational potential energy, equate that to the final kinetic energy, and then work out v from the equation. Kinetic energy equals a half mv squared. Then with practice, you would need more energy than this to achieve this speed, because some energy will be transferred to the surroundings. Now you've got to say where that will go to. So it could be work done in heating the air, it could be energy transfer due to air resistance or drag. Now the next question says, on another occasion the Falcon catches a small bird while gliding horizontally. Figure 4 shows the Falcon and the small bird gliding horizontally in the same direction at constant speeds. The Falcon collides with the small bird and grips it tightly. The mass of the small bird is 0.18 kilograms. The initial speed of the Falcon is 25 meters per second. The initial speed of the small bird is 12 meters per second. So state the law of the conservation of momentum and then calculate the speed of the Falcon immediately after this collision. So pause the video now, then unpause the video when you want to go through your answers. Right, so you've got to learn what the law of conservation of momentum is. Just a fact you've got to learn, and that is that the total momentum before and the total momentum after are constant as long as there's no external force applied on the system. Don't forget that second part. Now to calculate the speed, what you've got to do is look at what information you've got. So you've got the speed of the Falcon, you've got the mass of the Falcon, and you've got the mass of the small bird, and you've then got the initial speed, of the small bird. So what you can do is beforehand you can work out your total momentum by timesing the mass of the Falcon by its speed and the mass of the small bird by its speed. You then add them together. Now if the momentum is conserved, the total momentum before is equal to the total momentum after, so that total momentum is then the same for the two objects combined afterwards. Then you would divide that by the total mass of the two objects to work out your speed, which is 23.2 meters per second. The next question says, Figure 5 shows an aircraft that is initially in level flight at constant velocity. Identify the forces P, Q, R and S acting on the aircraft. Then figure S is increased to a new constant value. State and explain any change in the horizontal and vertical motion of the aircraft due to the increase in S. So pause the video now, then unpause the video when you want to go through your answer. Right, so what forces will be acting on the object? Now again, it tells you that it's in the air, so acting down is going to be easy. R is going to be weight. S again is going to be the thrust of the engine or the motive force. Q is going to be the drag or the air resistance because we're in a fluid. Now again, because we're in the air and we're not on the ground, it can't be the reaction force. Because we're in air and not a liquid, it can't be upthrust, so therefore it has to be the force that acts on an object upwards when it is air, which is lift. So you can see it go through there. Now if S is increased, what will happen? Now again, think about it, it's 3 marks here. So firstly the speed will increase, or the aircraft will accelerate because there's now a resultant force towards the left. But because it's now accelerating, the air resistance or drag force Q will increase. Eventually they will equal out and you'll get terminal velocity. So they've got a new constant speed. But again, as there's a new speed, as a new faster speed, that tells us that lift is going to increase because the speed of the aircraft will affect the lift, so therefore it will also accelerate upwards as well. The next question says, on another occasion the aircraft is flying horizontally when force P is increased to 9.87 kilonewtons. The aircraft climbs with constant vertical acceleration and the weight of the aircraft is 9.60 kilonewtons. Show that the vertical acceleration of the aircraft is approximately 0.28 meters per second squared and that the aircraft climbs with a constant acceleration through a vertical distance of 500 meters. Show that the magnitude of the vertical component of the velocity of the aircraft at the end of the climb is approximately 17 meters per second. So pause the video now, then unpause the video when you want to go through your answer. So in this question, what can we do? Well, we're given the force, okay, and we're given the acceleration, and we need to work out. So we need to work out the acceleration, and we're given the mass. So what we do firstly is we've got the weight, so we can then convert that back into the mass by saying the weight is going to be equal to mass times by gravity. So therefore, mass is weight over gravity. Again, convert the kilonewtons into newtons by saying it's times 10 to the 3. So we get our mass to be 979 kilograms. We know what F is. Now we're going to remember F is the resultant force, so it's going to be the force upwards minus the force downwards, so therefore it's 9.87 minus 9.60. We then convert that into kilonewtons to see that it's 270 newtons. We then say F equals ma, work it through, and we get 0.276 meters per second squared. The next question, again, it says it climbs through a distance of 500 meters, show that the magnitude of the vertical component at the end of the climb is 70 meters per second. Now we can use SUVAT. We look at what we have. We've got S. Yeah, yes we do. We've got A, yes we do. We've got U, yes we do. We want to work out V. So what can we do? Well, V squared equals U squared plus 2AS. Pop in all the numbers and you get 16.7 meters per second. It's very important you write out the equation and you then pop the values into the equation. The next question says, during the climb, the aircraft has a constant horizontal component of velocity of 70 meters per second. Calculate the aircraft's resultant velocity at the end of the climb. So pause the video now and then unpause the video when you want to go through your answer. Right, so when you're doing this question, you can always think you've got your vertical component, you've got your horizontal component. Now there's two ways in which you can do it. You can either draw a scale diagram if they're not at 90 degrees to each other, but because they are at 90 degrees to each other, the easier way would be to use Pythagorean theorem. So you've got your constant horizontal component to be 70, you've got your vertical component, to be 16.6, so therefore to work it through, it's 70 squared plus 16.6 squared, all square rooted is 72. You can then, if you draw your right angle triangle, realize that the opposite is going to be the vertical, which is 16.6, and the adjacent is the horizontal, which is 70. So tan to the minus 1 is 16.6 over 70, because tan is equal to opposite over adjacent, TOA in soccer TOA, so you get 13 degrees from the horizontal. We're now going to look at some questions involving electricity. So figure 5 shows the main parts of an X-ray tube. Electrons are emitted at the cathode and accelerated onto the anode. The operating voltage between the anode and cathode is 80 kilovolts. The tube current is 100 milliamps and the tube is switched on for an operating period of 5 milliseconds. Calculate the number of electrons that reach the anode during this operating period. Energy that is not emitted in the forms of photon is transferred to internal energy. The efficiency of the X-ray tube is 2%. Calculate the increase in the internal energy of the anode. Then the tube current is now increased. The operating voltage and the operating period are unchanged. State and explain any effect that the increased tube current has on the X-rays produced. So pause the video now, then unpause the video when you want to go through your answers. Right, so in this first one, what do we have? Well, we know that we have our current and we know we have our time. So we can therefore say that Q equals IT. Now again, to convert the milliamps into amps and the milliseconds into seconds, and we work it through to be 5 times 10 to the minus 4 coulombs. Now we know that one electron has a charge of 1.6 times 10 to the minus 19 coulombs. So therefore the number of electrons is going to be the total charge, 5 times 10 to the minus 4, divided by the charge of one electron, 1.6 times 10 to the minus 19, to get 3.1 times 10 to the 15 electrons. Now remember that in this case that we've got an efficiency of 2%. So 98% of the energy is going to the internal energy. So the first step is to work out your total energy. Now you can say energy is equal to QV. So we've got Q, we've got V. Remember we're going to convert our kilovolts into volts, and we've got our charge from the previous question to work out the energy to be 40 joules. Now 98% of that goes to the internal energy. So to convert the percentage into just a value, it's 0.98, because percent means divide by 100, so therefore it's 0.98 times by 40 is 39.2 joules. Now what will happen to the increased current on the X-rays produced? Well, if you have an increased current, well, there's more electrons emitted, so therefore more photons will be emitted, so therefore the intensity of the X-ray beam will increase and the frequency of the photon will be unchanged, because you're not changing how much energy the electrons have and therefore the photons have, rather you're changing how many of them hit the surface. The next question says, superconductors can be used in electromagnets in some types of trains. Explain what is meant by a superconductor and explain why superconductors are used in these electromagnets. So pause the video now, then unpause the video when you want to go through your answer. Right, so what's a superconductor? You've got to learn this definition. It's a material whose resistivity is 0 below the critical temperature, and you've got to learn all those words. Now, why are superconductors used in these types of magnets? Well, it can generate strong magnetic fields, so they can stay in large currents because there's very little energy lost due to resistance, because there's no resistivity, so therefore there's no damage due to overheating due to energy transfer and energy dissipation. We're now going to look at some questions regarding further mechanics. So figure 1 shows a student moving a bucket of water in a vertical circle at a constant speed. The centre of the circle is marked with an X and the bucket is attached to a length of string. The water moves in a circle whose centre is at X. Draw on figure 1 an arrow to show the direction of the resultant force acting on the water. Then at the top of the circle the angular speed is just sufficient to keep the water in the bucket. Explain why the centripetal force on the water is equal to its weight at the top of the circle. So pause the video now, then unpause the video when you want to go through your answer. Right, you can see straight away that it's going to be a centripetal force, and the resultant force of a centripetal force is always acting towards the centre of the circle, so it's acting towards X. Now, why is the centripetal force of the water equal to the weight at the top of the circle? Well, it's the idea that the reaction force is at that point 0, so therefore the only force that's acting on the object is the weight, and the weight therefore is the resultant, and the resultant force towards the centre is called the centripetal force, so it all works through. The next question says, the radius of the circle is 0.85 meters. Calculate the angular speed of the water. Then the student gradually increases the angular speed until the string breaks. The student plans to repeat the procedure. He wants to achieve a greater angular speed without breaking the string. He plans to use a new piece of the same type of string and the same bucket. Discuss 2 changes that the student can make to move the water in a vertical circle at a greater angular speed without the string breaking. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, we know that the weight is equal to the resultant force. So we know that the weight is equal to mass times acceleration. So therefore we can say that mg is equal to mr omega squared. Now the 2 m's will cancel through to say g is equal to r omega squared. So omega, which is what we're trying to work out, the angular speed, is the square root of g over r. Pop in the values that we know, and then you get your answer to be 3.4 radians per second. Now for this next question, we know that the tension in the string is equal to 2 things. It's equal to the weight, which is mg, plus the centripetal force there, which is mr omega squared. Now when they are at maximum value there, maximum tension, which is important because you want to work out the maximum, because that's when the string is going to break at the maximum tension, not the minimum. The maximum is going to be when the 2 are added together, so mg plus mr omega squared. So what can we do? So we can reduce m, because if we reduce m, we'll reduce the tension, so it's less likely to break. Or what we can do is we can reduce the radius of the circle r, because again in mr omega squared, if we reduce r, we'll reduce the maximum value of t, so it's less likely to break. Obviously we can't actually do anything with omega, because it's already said we're going to have a greater angular speed, so we can't do anything with that. Alright, the next question says, figure 2 shows a tuning fork with a small piece of clay attached to it. The tuning fork is made to vibrate. The clay string stays attached to the tuning fork, and the figure 3 shows the tuning fork and the clay vibrating. Figure 4 shows the variation of acceleration of the clay with displacement from its equilibrium position. Explain how figure 4 shows that the motion of the object of the clay is consistent with the conditions for simple harmonic motion. So pause the video now, then unpause the video when you want to go through your answer. Right, you've got to know here what the condition of simple harmonic motion. So because we know that simple harmonic motion shows acceleration and displacement are directly proportional to each other, but one is in the opposite direction to each other, well, to show direct proportionality, we should have a straight line through the origin, which we do. Now to show that that one is in the opposite direction, it has to be a negative gradient, so you can see here that it's sloping downwards, so therefore it's proven the condition of simple harmonic motion. The next question says, show the frequency of the vibration of the clay is approximately 700 Hz, calculate it in meters per second the maximum speed of the clay, then label with P on figure 4 the position of a point in which the clay is travelling at its maximum speed. So pause the video now, then unpause the video when you want to go through the answer. Right, how to answer this question? Well, we know that we can work out our acceleration and displacement from the graph. So we can therefore say A is equal to minus omega squared x, and omega equals 2 pi f, because omega is just going to link into that with that particular equation. You can sub it in, so therefore acceleration is equal to minus 2 pi f squared x. We can then read off a value of a from the graph, read off a corresponding value of x from the graph, rearrange to make f the subject, and we get 660 Hz out as the answer. The next question says calculate the maximum speed. Now we know that the Vmax from the equation sheet is equal to A omega, or 2 pi f A. Now we know that the amplitude, which is A, is 1 millimeter from the graph because it's the maximum amplitude. Now we also know what F is from the previous question, so therefore we can work it through and we get 4.2 meters per second. Now label with P on figure 4 the position of the point where the clay is traveling its maximum speed. Well, the clay is going to be traveling the maximum speed at 0, 0. Why is that going to be? Because it's traveling at its maximum speed where the acceleration is going to be 0. So that occurs when there's no displacement. So it's going to be at the 0, 0 point, because remember, acceleration is directly proportional to the negative displacement. So if we've been successful and we've learned in today's revision session, we should be able to answer A-level physics examination style questions, assess our own understanding on A-level physics, and understand what topics we need to improve upon for AQA A-level physics. So thank you very much for watching this revision session on paper 1 for AQA A-level physics. Thank you very much and have a lovely day.